A new revolution has taken flight in a world where the traditional airplane engines once dominated the skies. Electric plasma engines are breaking shackles by harnessing the power of electric plasma, sparking a greener, cleaner, and electrifyingly efficient era of flight. Are electric plasma jet engines really the game changer we've been waiting for in aviation sustainability? Will electric plasma jet engines pave the way for a greener future? Or are there hidden drawbacks? Join us as we unveil electric plasma jet engines where innovation meets sustainability. We explain the technology, the process leading up to its discovery, and the impact it has on the future in terms of sustainability. In 2018, the Environmental and Energy Study Institute revealed that aviation produced 2.4% of total CO2 emissions in 2018 in the heart-pounding race against climate change. Where the future of aviation teeters on the edge, a trailblazing Chinese research team has unleashed a breathtaking innovation that promises to shatter the chains of fossil fuel dependence. Fueled by an audacious vision, the electric plasma jet engines aim to revolutionize modern airliners by enabling them to fly across the globe solely powered by air and electricity. What's going to make it possible? Plasma. This here is a model of a plasma engine. Look here. Here's where plasma is converted into that energy that is used to power the engine. Plasma, one of the four fundamental states of matter, holds a prominent position in the universe. Astrophysicists confirm its abundance and that it was the first state created after the Big Bang. Generated through the ionization of molecules at high temperatures or electric fields, plasma is present in stars, the sun, and other celestial bodies. The state of matter can also be artificially produced by heating neutral gas or exposing it to strong electromagnetic fields, such as microwaves and lasers. Its diverse applications include artificial crystal growth, medical treatment, television screens, and environmental studies. Led by the determined Professor Zhao Teng, a team of researchers embarked on a quest to explore the potential of using microwaves in synthetic diamond production. However, their path took an unexpected turn when they wondered if this technology could be applied to create thrust. With experts from Wuhan University's Institute of Technological Sciences, they published a groundbreaking paper on jet propulsion by microwave aeroplasma in the spring of 2020. Critics questioned whether this is really a Chinese discovery or a derivative of pioneering inventions by US scientists connected to NASA. According to Professor Teng, the motivation of our work is to help solve the global warming problems owing to humans' use of fossil fuel combustion engines to power machinery, such as cars and airplanes. There is no need for fossil fuel with our design, and therefore, there is no carbon emission to cause greenhouse effects and global warming. Their remarkable prototype achieved the seemingly impossible, propelling a 2.2-pound steel ball over a quartz tube using only 400 watts of microwave energy. The team's genius Professor Teng hinted at the extraordinary possibility of constructing high-performance microwave aeroplasma jet thrusters that might one day replace conventional fossil fuel jet engines. Plasma thrusters have found use in modern spacecraft and aerospace applications. Some of these thrusters employ internally generated currents and potentials instead of high-voltage grids, anodes, and cathodes. Though they offer advantages such as simplicity, safety, and efficiency, they operate at a lower exhaust velocity due to the absence of high accelerating voltages. Prominent space agencies, including the European Space Agency, Iranian Space Agency, and NASA, have developed various forms of plasma propulsion systems. However, the technology remains unsuitable for Earth's atmosphere, as even spacecraft plasma engines yield limited thrust due to the substantial power intake required for operation. Engineers worldwide are grappling with adapting these engines, as accelerated ions lose much of their thrust force to air friction. The persistent challenge lies in developing a portable power source that can generate enough thrust to lift an aircraft with passengers and baggage. Fossil fuels contain a vast amount of energy that current batteries cannot match in terms of storage capacity. The heart of the challenge lies in the voracious appetite for energy that these plasma engines demand. Even a formidable electro-thermal thruster, the variable specific impulse magnetoplasma rocket, hungry for its space-faring ambitions, devours a staggering 200 kilowatts of electro power, all for a mere 1.12 pounds of coveted thrust. Yet, the team remains undaunted, for within their grasp lies the tantalizing prospect of soaring skies. Forged in the fires of their laboratory, a daring prototype emerges, bearing the promise of a plasma-driven future. As they navigate the treacherous path from the minuscule to the mammoth, the weight of this dream becomes apparent. Bottling such power for terrestrial flight threatens to burn in an aircraft beyond its wings' capacity. But as the embers of doubt flicker, a more ominous foe lurks, a shadow cast by the searing plasma itself. Fueled by the very stars that ignite the universe, the inferno within could consume all in its path. The risk of catastrophic plasma erosion looms, threatening to devour the very heart of the thruster, leaving a void where dreams once took flight. Before we continue, hit that like button and subscribe to our channel for interesting upcoming videos. With resolute determination, the team embarks on a crusade of experimentation, seeking the perfect alchemy of materials and construction. A potent and safe engine that defies the naysayers. Their ambitions soar, but Western analysis raised skeptical eyebrows, dismissing their audacity as folly. MIT professor Steve Barrett's dissenting voice echoes, likening their endeavor to a whimsical stovepat experiment, a rattle of the valve, an illusion of thrust. But these pioneers know they stand on the precipice of greatness, driven by a relentless pursuit of knowledge and unyielding determination. Amidst the intrigue, whispers emerge from the vaults of secrecy. The Wuhan team guards their data, concealing the highest microwave power levels and maximum airspeed of their Chinese prototype. Speculation runs wild. Could this secrecy be a cloak for the hidden flaws of the engine at high power levels? Or perhaps a safeguard against prematurely unveiling a work in progress? The Wuhan researchers, guided by the visionary Professor Tong, stand at the precipice of greatness, ready to scale the towering heights of the skies. With fiery determination, they forge ahead, assembling an array of prototypes adorned with the thunderous might of high-power microwave sources. Gradually, they ascend the ladder of progress, inching ever closer to their audacious vision, a full-size jet powered by the elusive essence of plasma. Yet the pinnacle of their ambition remains shrouded in mist. Plasma jet engines for massive commercial aircraft. Professor Tong, a sage amidst the stars, reveals the monumental challenges ahead. To propel a jumbo jet with this celestial marvel, they must harness a formidable arsenal of megawatt microwave sources, higher power turbine compressors, and an electric energy storage capability that defies imagination. A journey spanning another decade awaits, a quest for engineering marvels of epic proportions. In the crucible of innovation, the team persists, unwavering in their purpose. Awaiting them is the promise of a future unbound by the chains of fossil fuels, where small drones and mighty cargo aircraft bear the emblem of sustainability. Professor Tong's eyes gleam with the certainty of change as he envisions an aircraft fleet infused with the cosmic power of plasma. Undeterred by the arduous path ahead, they turn their gaze to the stars, beckoning a new era. An era where aviation, once captive to carbon emissions, breaks free from its earthly confines. Plasma jet engines, radiant and untamed, hold the key to untold potential. With each breakthrough, the chorus of hope swells, resonating in the hearts of all who yearn for a greener world. As the wheels of progress turn, they paint a canvas of transformation, a world where fossil fuel consumption dwindles and greenhouse gas emissions fade into obscurity. The skies, once tainted by carbon dioxide, now bear the promise of a cleaner horizon, thanks to the electrifying force of plasma propulsion. The stage is set, and Professor Tong and his valiant team stand poised to carve their names in the annals of history. The future awaits, ablaze with possibility. For if this daring design stands firm, it heralds the dawn of a new epoch, an epoch where the winds of progress are driven by non-fossil fuel-powered aviation propulsion. The world holds its breath in awe, knowing that in their hands lies the power to redefine the very essence of flight. With unwavering dedication, their brilliant minds embark on the path of discovery, seeking to unlock the secrets of plasma jet engines. A revolutionary concept unfolds, where electricity supplants traditional fuels and electromagnetic fields breathe life into the very heart of propulsion. Picture this. Argon gas, compressed and awakened, dances with electric fervor, giving birth to a magnificent plasma akin to the fiery core of a fusion reactor. Within this celestial dance, a radical transformation takes shape, and the carbon dioxide emissions of jet engines are slashed by more than half. As the veil of tradition lifts, a new age dawns in aviation. The skies above become a canvas of innovation, with plasma jet engines painting a masterpiece of sustainability and progress. The sheer power of plasma unleashes possibilities beyond imagination, propelling aircraft with grace and efficiency. The world watches in awe as these futuristic engines take center stage, spearheading a paradigm shift in flight. Step by step, the promise of plasma jet engines draws nearer to reality. Eager minds toil tirelessly, refining the technology that will shape the destiny of air travel. With every milestone, the vision of cleaner skies draws closer. The carbon footprint of aviation retreats, and the world breathes a sigh of relief, knowing that a more sustainable future is within reach. But how big is the impact and potential? According to a University of Illinois at Urbana-Champaign study, plasma engines could emit up to 60 less carbon than regular jet engines. That is a massive improvement on the current situation, and an insane big impact on sustainability and carbon footprint. That means the contribution to CO2 emissions from the aviation industry will drop to about 1% of global emissions. We can then all get back on the plane with peace of mind. This game-changing innovation on the horizon prompts the question, what amazing enhancements may we achieve by fully utilizing plasma engines? What impact might this have on the future of transportation as we know it? Our expectation is that this is going to have a mega positive impact on CO2 emissions and make the aviation industry more sustainable. What are your thoughts on this? Leave your answers in the comment section below, and don't forget to like this video to subscribe to our channel if you haven't already.